Welcome to the Colmet Academy. We are hosting a series of webinars and we appreciate you joining in. Today's topic is spray booth sizing and selection. My name is John Ode and I have responsibility for sales and marketing at Colmet. For those of you that have visited our facility, we appreciate that. And for those of you that have not, we certainly would welcome, and when the opportunity presents itself, we'd like to host you. We're located in Rockwall, Texas, which is about an hour east of Dallas. We have a 150,000 square foot facility where we have our corporate headquarters, and then we do all of the manufacturing for the products that we make. When you look at the Colmet products, we basically have three main business segments. We have our core or catalog equipment. So these are standard booths, liquid and powder. We have batch ovens and a variety of other pieces of equipment to help facilitate the finishing process as well as the environment around that. We also have our engineered projects group, or what we call EP. This is more complex, larger format spray booths. We can do part washers, elevated ovens, process ovens. When we say process, we're talking about moving line typically. And so we have a lot of capability to engineer those components to meet specific customer needs. And the third part of our business is RP filtration products. So Colmet acquired the RP product brand from April Air in 2017. 2018, we integrated it into our manufacturing facility. So we manufacture all the split and expanded paper filters with the polyester backing. We are the only spray booth manufacturer that also manufactures our own filtration products. And because of that, that's why we can offer a 5-year warranty on our spray booths if our filters are used. Today, we'll mostly be talking about liquid booths, so the conversation will be more around the core and catalog equipment, but you'll also see some of the larger format booths as we talk through some of the different examples. As far as our overview, we're going to talk about, first of all, is why do you need a spray booth? We're going to look at the major components that make up a spray booth. We're going to talk about the various types of spray booths and guidelines that OSHA and NFPA put out regarding airflow requirements. Then we'll look at the two major classifications of spray booths, which are cross and downdraft. We'll show you how we do the airflow calculations, and it does differ a little bit, and we'll explain that. We'll also talk about how do you size a spray booth for a particular product, and then we'll look at some of the upgrades that you can do to enhance the performance of the spray booth. So first off, why is a spray booth required? Well, the function of a spray booth is to combine and evacuate the atomized particulate and vapors associated with a spray application. So when you're atomizing paint, you have solids and you have vapors, and what the booth does is it captures those and keeps them confined. It also prevents the overspray of the volatiles from migrating throughout a facility and causing contamination. Or, you have sometimes when you're in a facility, maybe areas or people outside of the spray operation complain about odors and smells. Well, that's because maybe the booth isn't operating properly or it hasn't been optimized for that application. And so having a spray booth helps contain all that. And really it provides a clean environment in which to paint and minimize contamination in the coated product. In the picture that we're using as an example here, you can see this is for an automotive application. So this is an enclosed booth. The air is filtered coming in and exhausted, and you're working towards obtaining a Class A finish, so we want to protect that. Another thing that the spray booth does for you is it prevents a combustible combination of flammable vapors and air being created, where then if you had some type of a static spark, you could get an ignition, and you definitely want to avoid that. And probably the most important reason why you need a spray booth is because OSHA and NFPA say that you must have one to, for all the reasons we talked about above, is to create a safe environment. When we look at a spray booth, it consists of, the major components are the work area or the compartment. We have the exhaust chamber where the filter media is. So the exhaust filter is mounted on the face of the filter chamber. The exhaust is behind that. And so now you entrap the paint particles in the exhaust filter. And then the exhaust fan is ducted to the exterior of the building to remove the harmful vapors. Spray booths can be open-faced or enclosed. So you see the example above. With an open-faced booth, you do risk pulling in dirt and debris from the environment around you into the finished product. But if you're painting structural steel and really your main objective is to just coat that product with as much primer maybe as you can get on to stop it from rusting, you're not worried about a little bit of dirt and dust, and so you don't want to go through the expense of maybe having an enclosed booth with filter there. Again, the lower example, you're doing an automotive or you're doing automotive parts, you want a Class A finish. So there you want an enclosed booth. You want to filter the incoming air and ensure that you have exceptionally good, clean air flowing through that booth. When we look at the major components of spray booth, this gives you a breakdown on those. Again, the filter chamber, you can see the filter media here. One thing I want to mention, in this example or this illustration, you see there's 16 20 by 20 filter pads. And these would be, with Colemet, we would ship our RP pads. One of the changes that we've recently made, so any booth you order now will actually have blanket media. So instead of having 16 individual filters, you're going to have 2 large blankets for a booth this size. And then using our filter lock system, those filters will lock in place. And so it gives you a system where you can change the filters quicker, and you get also a much better seal to prevent the opportunity for overspray bypass. Also, we look at the light fixture in this illustration too. Really, the number of lights vary based on the size of the booth. All of our booths are designed to give you 300-foot candles or 100-foot candles at 3 feet off the floor. Another change that we've made this year is that all of our booths ship with LED lights. All of our LED lights are true LEDs, and the benefit of that is you get more true light rendering, but you also get about a 50% reduction in energy usage. Across the top face of the booth, there's a vertical piece of metal. It's about 4 to 6 inches, and that's basically a fire curtain. That is a code requirement in all booths. And so if there were to be a thermal incident inside the booth, as all booths need to have fire suppression equipment, that would stop flames from rolling out and give the suppression an opportunity to put out any type of situation that might be in there. An important part of the booth, too, that gets quite often overlooked is the manometer. So all booths really are required to have a visual indicator that tells when the filters are loaded. And so really the simplest, most cost-effective is a manometer. So these are provided with all booths. Quite often that you see, though, is that they don't get connected. And that's not a good thing, because this is like a $5,000 OSHA fine if you don't have this connected and you would happen to get an inspection. So what the manometer does is it looks at the pressure differential between the spray chamber of the booth and inside the filter chamber. And so it's an indicator of when the filters are loading. Most booths will start out at 0.05 inches of static when the booth's new and the filters are clean. And so what you want to do is find that point. Again, when the booth is new, you put the green arrow on there. And then when you get half inch of static, that's when you want to talk about changing the filters. So as that climbs and reaches that point, that's your indicator to know that it's time to change the filters. So one question that we get a lot is, well, how often do I need to change the filters? And it's not a question that we can easily answer, because it really depends on a lot of variables. How much paint is being sprayed, how close is the operator to the filters, what's the type of paint. And so really what it is that we have some customers that might change filters once or even twice a day if they're running multiple shifts. And then we have some customers that change filters once a month. Obviously, since we manufacture filters, we kind of like the ones that change them every day. So those are some of the major components. If you look here, then this is the exhaust chamber. Again, the filter media is mounted at the face. The fan is above it, so we draw the air through, up and out the exhaust. When we look at spray booths, there's typically 2 designations, and spray booths are really always designated by the direction of airflow. So the first example we have is a cross-draft booth. In this style booth, the air is moving horizontal. So in this case, this is an automotive booth. You have filtered doors. The air is being drawn across the vehicle and then exhausted out. And then the other is a downdraft booth. And then here the air is predominantly vertical. So the air comes in from above, travels down. In this case, we have a pit centrally located in the middle of the booth. There will be grating over the top of the pit, and then your filter media would be below it, and then the air is drawn out and exhausted. So those are your 2 predominant booth styles. Now, the airflow in those 2 booths when they're designed, can differ a little bit. And really what guides us on the volume of airflow is OSHA and NFPA. Now, I don't profess to be an expert in OSHA and NFPA. We do have people within Colmet that if you have a customer that has detailed questions, or if you yourself have detailed questions, we can put you in contact with the people within our organization that have more expertise. But really just to look at the highlights, one, this will give you some direction where to go. Certainly you can look at the official OSHA and NFPA documents and get much more detail. But for me, just to give you a quick highlight, OSHA 1910-107, the airflow is not to be less than 100 linear feet per minute. If you have an electrostatic application where you have higher transfer efficiencies, so less overspray, the airflow then can be lower, but not less than 60 linear feet per minute. OSHA 1910-94 references table G10. I didn't put that in here because that's kind of an eye chart. It's a bit confusing, but ultimately what it says is that required airflow velocities ranging from 50 to 250 linear feet per minute in the opening of a spray booth. And so we'll kind of come back and talk about that. OSHA 1910.94, now it talks not so much about airflow, but it talks about the lower explosive limit, and it says that it has to be at least 25% or lower than 25%. NFPA then also follows along that. Chapter 7, which deals with ventilation, specifically Section 7.2, the performance requirements, it says that the ventilation or the air within the booth shall not exceed 25% of the lower flammable limit. So one talks about LFL, the other LEL, and those can pretty much be used interchangeably. So those are the guidelines really for designing a spray booth. So now we'll see how that correlates to the two predominant styles that we discussed. So with a cross-draft booth where the air is flowing horizontally, here we have a simple industrial booth. We would call it an IB booth. The formula for calculating airflow is you take the width of the booth times the height times 125 feet per minute. Now, we did say that the code requirement was 100, but for our catalog or standard booths, we designed them for 125 feet per minute. This gives you the opportunity to have a little more filter life and also allows you some working area if you're going to add openings other places the booth will touch on. So with this booth, it's 10 foot wide, 10 foot high. That means we have 100 square feet on the face. We're designing it for 125, so that means that we need a fan that can pull 12,500 CFM or cubic feet per minute through the face opening of that booth. So here you can see there's two examples. So we go back to this picture we looked at earlier. This booth is about 10 foot high and 40 foot long. So you can imagine that's 4 times bigger. So that's going to require about 50,000 CFM of airflow. And you can see that we have 2 relatively large fans on that booth to pull that air through. If you can get by with a narrower booth, in this example it's 10 by 10, here we only need 12,500 CFM. So 1, the investment for the booth will be less. 2, you're also exhausting less air. It's important to manage how much air you're exhausting because you need to make up that air. And if you're somewhere where it's cold outside and, you don't want to be pulling cold air into the building, so, it involves energy savings. So a long booth like this is nice. Maybe they're doing metal structural steel, but if you could take a long part and put it in a narrower booth but have increased depth, then you could have lower operating costs. So, booth selection really comes down and surrounds, what is the part style, what are the requirements, and then, Colmet regional sales managers can help you make a recommendation to your customer. So the cross-draft booths come in a variety of shapes and sizes. We have what we call our exhaust chambers, where it's just basically a filter wall. We have benchtop booths. We have the IB booth that we looked at. Now you can also take that in if you need cleanliness or you want to cut down on some of the debris, you can add filtered doors. There's also variation. So the first example, we talked about the cross-draft booth here. We have filtered doors and you're drawing the air across. We also have what we call a semi-cross-draft booth. So in this case, what we're doing, instead of having filtered doors, we have solid doors, and we have filtered air coming in through the top. So the air is drawn down and then across the booth. Some people like this booth because what it allows them to do at a later date, as they want to maybe upgrade or improve their capability, they can add an air makeup unit and attach it here. When you add an air makeup unit designated specifically for a booth, now we call that a pressurized booth. And there's many advantages of a pressurized booth because now you can control the airflow in the booth and adjust it as the filters load to maintain consistent airflow. So these are some of the different variations. And a lot of these booths we look at here are, very versatile. Another application for cross-draft booth is more on automated systems where there's a conveyor moving through the booth. Now this happens to be more of a manual push-pull type conveyor system where parts are put on, pulled into the booth, and then sprayed. But you could also have an overhead conveyor or a chain on edge floor mounted conveyor. When you start adding openings to the side of the booth, those are going to also draw air. Air will always take the path of least resistance. And so when you're designing a booth or when you're selling a booth, it's important that you take into account all the openings. So in this example, we're just saying, all right, it's a 1 foot by 2 foot opening. That's additional 2 square feet. We have a total of 104. If we're engineering a booth for you, then we will default to the 100 feet per minute. Or if you feel that the installation warrants it, we can design it for whatever airflow you want. One thing to keep in mind is the higher the airflow, the more overspray it's going to pull. And in some instances, like if you're using a rotary atomizer where you have a softer spray pattern, you might not want a higher air draw. And also, like we talked about earlier, if you have an electrostatic application, you could actually design the booth to be at 60 feet per minute. So if you have special applications or electrostatic applications, we can work with you to design the booth. Another way to accommodate that would be to have a more upgraded control panel and have a variable speed or a VFD on the booth exhaust motor. Then you could adjust the airflow. But in this example, you could see that we could design the booth for 10,400 CFM. Now, one thing to note, and I mentioned earlier, that all of our catalog booths are designed for 125 feet per minute of airflow. Now, the minimum code requirement is 100. So what that means is that you could buy a standard booth and cut the conveyor openings in, and as long as the surface area of the conveyor openings is less than 25% of the booth face, you would still be at that 100 feet per minute. It's always a benefit if you can use a catalog or standard booth for a particular application and just make simple modifications on site because those are all pre-engineered and often a more cost-effective solution. So cross-draft booths, as we talked about, come in many shapes and sizes. So here's a couple examples where it's really been scaled up. The booth on the left, this is 135 foot wide, 60 foot high, 193 foot long. So this booth is sized this large because this customer is spraying portions that make up an oil platform that go out in the ocean. And so they need a lot of room to move around it. In this particular example, they're actually doing blasting and painting. So there's some additional controls and interlocks going on here, more so than a typical booth. But they need a lot of room to move around to put up the scaffolding to work on these components as they're building them out. So again, you can scale a booth as large as you need it based on the product that's being coated. Another example is of a locomotive being done in a cross-draft booth. Now, one of the challenges when you're looking at introducing air at one end and drawing it across the other is based on that distance, whether the overspray will make it all the way to filters. When you look at an automotive booth, which is typically 26 feet deep, the air movement will pull that overspray. But when you go and scale that for a locomotive and it's 100 feet, you may be challenged to get the overspray. Now, a particular booth might be selected based on the footprint or the budget, or for some reason it was deemed the best for this application. One of the challenges that you might have is you will get more overspray on the floor and have that to do more cleanup. The other style of booth is the downdraft booth, and this is where the airflow is predominantly vertical, moving from the top down. Now, the guidelines or the industry standard for designing the airflow in a downdraft booth is different than a cross-draft booth. Here, we're focused a little bit more on being less than 25% of the LEL or LFL. So now we're looking more at the number of air changes. The other thing that we take into account is that when you have a downdraft booth, you're typically spraying larger parts, and that part also occupies some of the volume in the booth that you're doing your calculation on. And because of that, you end up with an higher airflow, and we'll take a look at some of the examples. So the formula that's used for a downdraft booth is we take the width of the booth times the length, and for automotive booths, we multiply times 35 feet per minute. For industrial booths, where we're doing rail cars or heavy trucks, we use 50 feet per minute. And again, we're using lower velocities here. You can see in the calculation, if we take a 14 by 26 foot booth, that's 364 square feet of area times 35 feet per minute. The booth is designed for 12,740 CFM. Now, the same size booth for an industrial application at 50 feet per minute is 18,200. And again, we can go with lower velocities because the part in the booth takes up a lot of that area. And in the end, you actually end up with a higher airflow. Another thing that you have working for you in a downdraft booth is that gravity is assisting in moving the overspray into the filter media. And again, those are the reasons why we designed these booths at lower flow rates. With the downdraft booths, you have two configurations typically. You have your pit downdraft booth, where you physically have a pit in the floor. Again, you have grating covering it, your filter media is below it, and the air is typically drawn out through a single exhaust bag. Another example of a pit booth is here. Now, in this case, you can see that the pits were put alongside the walls of the booth. And again, based on the product that's being coated, how large it is, if there's a lot of gaps in it, if you're doing a car hauler, which is large but has a lot of open area, you may want the center pit. But if you have a large truck, that's basically like putting a large box in there, the pits on the side are probably going to be more effective because you don't have to draw it underneath and exhaust it. And so the booths can be configured in many ways. The other design for a downdraft booth is a side downdraft. In this design, basically, we put a filter plenum along the lower section of each of the walls. And that way you get that downward airflow and exhaust out each side. Now here you typically end up with exhaust fans on each side, so you have the addition of an exhaust, but you eliminate the need to construct a pit. There can be a lot of expense involved in building a concrete pit and then the associated path to connect it to the exhaust. So a pit downdraft or a side downdraft booth can be more cost effective than a pit downdraft, and you can get the same result with regards to airflow. This just goes into a little bit more detail, again, showing the detail on a traditional pit booth. The pit can be in the center or off to the side or some variation. Again, we designed this for lower airflow because the part is occupying a lot of that space, and then we have gravity assisting in the movement of the overspray to the filter media. And then in the side downdraft booth, again, another view of that. This is a typical side downdraft booth used for automotive repair shops. And so you can see the ducts on the side. One of the benefits of this also over the pits in the floor is that you have easier access to the filter media. So here the filter media is on the side. You don't have to remove a grating from the floor to access it. So that's one of the advantages. And also typically a side downdraft booth is going to be less of an investment because you don't have to construct the pit. So here's another example. Again, we talked about how we can scale booths based on the size of the part. So on the left-hand side here, we have a booth that's 130 foot long. Here we're coating windmill towers and blades in these booths. And so this is a very effective booth design with the downdraft airflow because we have access to all sides of the parts. In this picture, you get a good example of why we designed these booths for lower airflow. This would be considered an industrial application, so this booth was designed for 50 feet per minute. When I'm introducing the air up here, and now I've occupied about 50% of the space or more, that airflow is going to be, right around 100 feet per minute coming down the side to the filter media. So again, Those are some of the reasons why we designed downdraft booths with lower airflow, because the part going inside of the booth takes up a lot of space, and because of that, the resultant airflow is actually higher. When we compare the cross draft to the downdraft, and we talk about some of the reasons of why you might recommend one over the other, I just wanted to touch on a couple of those. One, typically a cross draft booth is going to be a lower capital investment. Again, you can spray a large part in this open face booth or this smaller one. It really depends on the application. Again, when you have an open front booth, you're not filtering the air, so depending on the product and whether you're trying to get a Class A finish or whether you can accept some debris or dust in the finished product, that could help steer you towards a booth. The other thing is a cross draft booth, again, is more cost effective. And for a part like a car, we have a 26-foot deep booth, you can pull that overspray efficiently to the filter media. But it's probably not the best application for a 100-foot long booth, because you will not pull that overspray. The overspray, based on the weight of the particles, will end up on the floor, so you're going to have more maintenance if you use a cross draft booth for a locomotive. And so typically for a larger, longer part, you're better off with a downdraft style side or pit for those applications. The other thing is when you have the downdraft booth, you can more freely move around the part as compared to maybe where you just have a single level of filtration drawing the exhaust. Again, so those are just a couple of situations. Another thing we talk about is underspray and overspray. So back to the example of the cross draft. If I'm spraying a car in this booth, I want the spray or the application to be in the direction of airflow. So I would actually start spraying the entire car from the back and work forward so that I'm putting the heavier paint layer over the overspray that's being drawn that way. With a downdraft booth, you have the flexibility since the air is moving uniformly. I mean, you still want to work top down, but you can start anywhere on the part and not have to worry about the underspray, overspray as much. So those, again, are just some of the considerations. Again, we have our regional sales managers that have a lot of expertise in helping make recommendations on booths. I think one of the things that's important always to understand the product that's being coated and then the class of finish that you're looking for on it. And then certainly we can help you make the most cost-effective recommendation to the end user for what type of spray booth they should have. So the next thing to talk about is sizing a spray booth. And really this is pretty straightforward. It really depends on how much access you need. Typical guideline is to have 3 to 5 feet around the part so that the operator can move around and have clear access. 3 foot really should be considered the minimum. If you've done spraying yourself, you think about holding a spray gun in your hand, you want to be, say, 12 inches away from the part, you can quickly absorb that 3 feet. So 5 foot is a much more comfortable number to have all around the part as well as above the part. The other thing to take into consideration is if you need to raise the part and spray underneath it to make sure that you have sufficient height above it. The further you can get away from the filter media, the better, because what that allows is for the overspray to disperse into the air movement and then be absorbed over the whole filter face of the booth. If you get too close to the filter media, then you tend to face load the filters quicker. So what we typically say is a minimum of 18 inches, but ideally you want to be 3 to 5 feet away from the filtered media as well if it warrants it. I visited an automatic installation about a year ago. It was a small booth. It was about a 4x4 booth. The customer's coating oil filters on a chain on edge line, and they had 2 stationary guns in the middle. Well, the filter media was about 4 inches behind the product that was being coated, and because of that, the overspray was quickly loading the filters right behind the part, and then the customer, because they were getting dripping and running, they had to replace the filters like every hour, and it really wasn't optimal. And if the booth would have been designed properly and had at least 18 inches or 3 feet away from it, that overspray would have had much more opportunity to disperse across the entire face of the filter media, and then they probably could have gone a whole day without having to change the filters because it was kind of a high volume application. So really having proper distance from the applicator or the part to the filter to allow that overspray to disperse and fully use the filter media is really something that you need to look at. Another thing is, not so specific to sizing a spray booth, but as you're looking to quote a spray booth, we need to understand what size you want to recommend to the customer. But a couple other pieces of information is what's the voltage and phase available, so we know how to size the controls and the fan motor. Most efficient is 480 volt 3-phase. However, not all places have that. It might be 240 volt single phase, but we need to understand that to make sure that we're quoting it properly, and most importantly, that when it ships, we don't have an issue where we don't have the right electrical controls. Another important piece of information to gather is the ceiling height, and this is needed so that we can have and quote the proper amount of exhaust duct work. So we need to get to go from the top of the booth to the roof deck, and then typically you need to go 6 feet up beyond the roof. And that can vary from state to state, but that's a typical guideline. One of the accessories for a spray booth, and in some cases a requirement, is an air makeup unit or an AMU. And basically what this is doing is replacing the air that's exhausted by the spray booth. According to NFPA Chapter 7, which is based on ventilation, Section 7.3, is you do need to replace the air that's being exhausted. I visited a customer probably about 2 months ago that had 2 large open-face spray booths. They were spraying racking for transporting parts, so the quality of the finish wasn't so critical. But what was happening was they had a large facility, but they had a welding operation at one end, they had the spray booths at the other, and they had no makeup air. So the booths were drawing all the welding dust and dirt. And although they weren't so concerned about the finishing, it was dispersing that all through the plant. Another issue they had was that the doors in the facility were very difficult to open or close because of that negative pressure they were creating, and that can also create a safety issue. So the solution that we did for them was we offered them what we call the demand unit, which is an air makeup unit that could basically dump air into that large building. And then the unit was interfaced with the booth, so if one booth was running, it operated a third of the power. If 2 booths were running, it operated the speed. It went to 2/3, and then when they had the welding operation, we could kick it up to full speed to replace all that air that they were exhausting. So that's one option, is that you can take an air makeup unit and physically just dump the air. You could use it through a stock, or you could have a distribution funnel into the room, and it's going to draw it to the booth. Air makeup units are available in a variety of configurations. You have vertical or horizontal or vertical units. You can see in these 2 pictures, these are horizontal units that are coupled directly to the booth. So in this case, obviously these booths are enclosed, so they want a Class A finish. This is what we would consider a pressurized booth. Again, the advantage of having a dedicated air makeup unit for the booth is now you can balance that booth and maintain the booth balance automatically based on the filter loading to maintain the air movement through the booth. Another thing that can be done when you have a dedicated air makeup unit on the booth is you could have a spray bake type booth where you can spray the part and then you could leave it, put it into cure mode. That air makeup unit can kick up to a higher heat output to help accelerate the cure of the part. So again, air makeup units are available in different configurations. They're typically sized for the specific booth if it's a pressurized booth, or we can make a demand unit that has higher output where you can feed multiple booths. And then the air makeup unit too, depending on ceiling height or space available, it can be mounted inside or outside the building. Another accessory for booths is doors. So we talked about booth doors, and really it depends on the type of finish that you're trying to obtain. So in some cases it could be that you add simple filter doors. Traditionally you might have solid doors if you have the air input from above, but also there's different variations, based on floor space available. We can do a roll-up door. We can offer bifold or trifold doors. We can also put doors at both ends of a booth and have pass-through where the part could actually pass through the booth. So a lot of times the larger booths for locomotives, or if the customer has a batch process where it's more in line, they can have doors at both ends and just move the part through their finishing process. So one of the things that we've done that kind of gives you a little bit of a summary of this presentation is we put together this industrial paint booth selection and sizing guide. It's more specific around the smaller industrial and standard booths, but it really kind of guides you through some of the things that we talked about in this presentation. It's a brochure that you could take with you when you go see a customer and kind of, give them an overview on the booth. You can talk about our 5-year warranty if they're using our Colmet W Series filters. You have a selection chart that shows a lot of the standard size and configuration. Again, the advantage of purchasing or selling a Dash S booth is it's typical available for a delivery within 10 days or less. However, we can make custom booths of any shape and size that you want. It goes through the illustration of showing the part and talking to the customer through, sizing how large of a booth they want. You have a section here that highlights all the major components of the booth. We have an area that shows some of the booth supplies. So we show our 3 W Series filters. All booths ship with the 5100 W Series filter. Again, I mentioned earlier that one of the changes that we've made this year is that all booths come with our filter lock, which is a channel that goes around the exhaust chamber, and then using the filter lock insertion tool, you can put the blanket media in. Now, the booths are still available if you want it with the 20 by 20 grid. However, you need to specify that. If you don't specify that, the booths will ship with blanket media, and it will be the 5100 W Series. Again, W is warranty. If you use our booth, our filters, we'll give you a 5-year warranty on the booth and the air makeup unit. We also have intake filters available, which are used for enclosed booths, booth paper. And then we also show some of the accessories that we offer. So if the customer wants, we can powder coat the booth white. This actually, we have listed an accessory, but now all Colmet booths, effective January 1st, 2020, ship with our LED lights. And again, these are 2 LED lights. They can give you much better light rendering in the booth, and they also have a 5-year warranty. Many booths go with basic control panels, but we do offer upgrades if you want a touch screen or more advanced controls for a booth. The exhaust ductwork, which we typically offer, and then again, some of the door options. The back page of the brochure is really a request for quote or an RFQ. And what this allows you to do is sit with the customer, fill in the information. You can put the size of the booth that you're looking for. If it's a standard booth, you can just put that standard number. Or identify the width, height, and length that you're looking for. We want to know the ceiling height again, so we can identify the amount of exhaust duct needed. If you know the pitch of the roof or the type of the roof, that would also help us fine-tune the quote to ensure that we have the proper flashing and things for the roof penetration. Again, electrical supply is important for us to know. Also the phase, whether it's single or 3-phase. And then if you have any specific needs for the exhaust filtration, again, we're going to provide the booth standard with blankets with 5100 series, and then any additional equipment upgrades. So you could basically complete this. You could scan it. You could take a picture, send it to us, and then we can develop a quotation for you. If you're looking to get a quote that's a little more in-depth, you can, on our website, access it at colmetsb.com. Along the top header, we have a quote request here. If you click that, it will bring up our RFQ. If you complete that RFQ and submit it, you'll, one, get an acknowledgement that we've received it. And then when we receive it, it goes into our queue, and our inside sales team will basically prepare a quote as they come in, first in, first out. Typically, we can turn a quote around in 4 to 12 hours. And so you'd see it typically within a day. Also, you can reach out to your regional sales manager if you have some more specific things. We also have a Colmet YouTube channel, and you can subscribe to that or visit it here. One of the things that we're doing with the webinars that we're hosting is we're posting them all there about a day after they're completed. And you can see here that we have our principle of spray booth exhaust filtration, which we did on Tuesday of this week. So you can access that. We also have some additional videos available on the filter lock installation, one on our tangent process, and then others just showing some of the capabilities. So we would encourage you to go there and, or direct your customers there to walk them through some of these things. If you need additional support, please feel free to reach out to your regional sales managers. These 5 gentlemen cover the territories that are outlined here. I also right now cover the Western Territory, so feel free to reach out to me. Again, I'm John Owed. Reach out to Trey if you have any questions on our filtration. Also, Casey works with him. Judy Litsky, our marketing manager, can help you out with any needs for literature, or if there's special promotionals that you'd like to run, please feel free to contact Judy. And again, our regional sales managers are available to help guide you to help with booth selection and any more complex projects that you may have. Also available to join you on sales calls with the end users. At this point, I'd like to say thank you for joining us. This concluded our booth sizing and selection webinar. You can see that we also have coming up our filter selection and review of case study webinar, as well as a webinar coming up on common NFPA and OSHA requirements for spray booth design. We ask you to check back with us, as we will be scheduling some additional webinars. Again, thank you very much.